are the notes. These are the notes for 3.5, the discriminant. And remember, the discriminant is b squared minus 4ac. This thing right here is a Greek letter called delta. Looks like a little triangle with one side fatter than the other. And delta is just a Greek, kind of the Greek letter for d. And it's just something we represent, oh, actually a lot of different things in maths, but we do represent the discriminant with delta. So a lot of times instead of writing discriminant, we write that. Okay, if the discriminant is less than 0, so negative in other words, then the quadratic has no real solutions. We'll talk about that in a minute, because I can't take the square root of a negative number in the quadratic equation. Should be quadratic formula, change that. And I'll just write that down. Okay, so if that were negative under there, I can't take the square root of a negative, so no real solutions. If it's positive, then it has 2 real solutions. So this thing, right, delta bigger than 0 means positive. And if it's equal to 0, it means that there's 1 solution. Sometimes they call it 2 identical solutions, but 2 numbers that are the same to me are just 1 number. This means that the quadratic is a perfect square. Okay, so here we go. If delta is a perfect square, then the quadratic can be factorized and the solutions will be rational. And if delta is not a perfect square, but positive, then the solutions be irrational. I'll give you some examples. Here we go. For each example, calculate the discriminant and thus determine the number of solutions and their nature. So I probably would write A equals 2, B equals 15, and C equals 13. And then I'd say delta equals B squared, so 225, that's what 15 squared is, minus 4 times 2AC, 2 times 13. And that turns out to be 225 minus 104. Feel free to use a calculator, which is 121. Now, if you know that 121 is 11 squared, that's fantastic. If you don't, take the square root of it so that you know. And I would state then the answer of this, the number of solutions and their nature. Well, the number of solutions is up here. So the quadratic is positive, so it has 2 real solutions. And if it is a perfect square, then the quadratic can be factorized and the solutions will be rational. Two real, maybe I would say rational. Rational just means I can write them as a fraction and that there aren't any surds in it. Okay, let's try this one. You can turn off the video if you want and try it, and then come back and look at it. I just put this in my calculator and I got negative 144. So my answer to this one is going to be that there are no real solutions. Because it comes up here under if it's negative, then it has no solutions. Oops, I'm off the page there, sorry. So I went back up here. I looked, it was negative, so no real solutions. Okay, this one, b squared. Why did I put positive 8? Well, I'll give you a hint. I should have started this question like this. Okay, before I can do the discriminant, it has to be in the form ax squared plus bx plus c equal to 0. So everything has to be on one side equal to 0. So that's why that turned into an 8. Okay, that gives me 9. Now remember, this is a negative times a negative. Okay, so it's plus 96. So it's 105. That's not a perfect square. 100 is a perfect square and 121, but not 105. So I would say 2 real irrational solutions. Okay, great. I'm going to pause for a minute. Okay, I'm on this problem here. It's got fractions in it. I don't want that to freak you out. The A is 81 over 4. I'm going to use my calculator in a minute. The B is negative 12, and the C is 16 on 9. So I'm going to go delta equals B squared minus 4 times A times C. Okay? You could type this whole thing in and get a number. I'm going to do that right now. Okay, if I were to do that, I'll try to get this all in the same lighting space here for you. I would go bracket negative 12 squared minus 4 times, and I'm going to do that thing where I hit math and then just go this arrow back and get that fraction and put 81 over 4 and then scooch out and then go times 16 over 9. Scooch out and I get 0. Okay. I would hope that you could do that by hand as well. This 4 is like 4 over 1, so these cross out. And the 9 goes in here 1, it goes in here 9, and 9 times 16 is 144, and 12 squared is 144. So you could do that by hand as well. Okay, let's look, what are we going to say? This is discriminant of 0 means, I'll put this up here again, discriminant of 0 means the quadratic has one solution. And it's going to be rational. Okay, I just want to talk quickly about this picture, and we'll talk about it also later in the week. But when a quadratic has no solutions, so the discriminant's less than 0, it means that the graph of that quadratic doesn't go through the x-axis. You know, if the A is positive, so it's going upwards, it's off the x-axis, and if the A is negative, it's going down, concave down, and it's off the x-axis. If it has one solution, it's this kind of thing, where it just hits one time. And if it has two solutions, so the discriminant's positive, then it goes through twice. Okay, I'll leave you some problems on Canvas.